Hey folks, in the last episode, I talked about breaking an x-axis. I showed you how you could do it in R, but I also said, don't do it in R. It's really a bad habit because ultimately it sends a mixed message to our audience. Our audience has a difficulty interpreting what that break actually means, and if it's not clear enough, then they might not see the break at all. It's especially problematic when it's on a y-axis. Oftentimes you might see a bar plot where there's a break in the bar. And one of the reasons that's problematic is that our eyes perceive areas, it perceives lengths. And so if you're putting a break in there, then our eyes don't really know how to compare that to other things. And so there's a variety of strategies one might use to get around needing to put a break in an axis. One thing you might do is really be more thoughtful about what groups you're showing. If one group is just so much higher magnitude than the others, do you really need to show all those others? Or perhaps you could pool those others and kind of show them in comparison and then have some kind of inset or some description to say what's in this other category. Another very popular approach is to put everything on a log scale that will compress everything down. The downside of that, of course, is that people don't typically know how to interpret a log scale. This is especially true of people outside of science. Another strategy that I talked about in my newsletter from back at the end of September, which you should be subscribed to, go down below in the description, and you'll see how you can get a hold of that newsletter and subscribe to it yourself. Another suggestion I had was to use facets, where you basically make separate plots. And so that way then you have some kind of boundaries on your plots to tell your audience that you have a break in one of the two axes. That's what I'm going to do today. In today's episode, we are going to put a break in the x-axis by using a facet. And those facets will hopefully make it clear that these are two separate plots. They're perhaps the same data, but separate plots. The data I'm working with is simulated from a study published by Anthony Petkidis, sorry if I'm butchering your last name, and colleagues, called Pre-existing Cell State Rather Than Stochastic Noise Confers High or Low Infection Susceptibility of Human Lung Epithelial Cells to Adenovirus. In their figure 3, looking at panels E and F, they have these breaks. And so the last episode, I did my best to recreate panel E. This is my attempt to recreate their figure. If you want to get a hold of this video, I've got a link up here I'll put in the upper corner where you can go back and watch what I did here. Really got into a lot about using stat summary to summarize data, to get a median as well as a 95% confidence interval. And then, of course, the star of the show was putting in this simple little break in the x-axis. So again, what I want to do is take a fairly similar approach to summarizing the data, but then to put it into separate facets. So I'm going to review using stat summary to make those confidence intervals as well as the points, and then show you how we might go about using a facet to give a stronger indication that there's kind of two things going on here. Over here in our studio, I have the code that we started with in the last episode. If you want to get this code as well as all the code I generate today, down below in the description, there's a link to a blog post that you can go to and you can get this code. So we'll go ahead and load all of this. This gets us a data frame called eData for panel E of that figure, where we've got the condition, the week, and then the Spearman correlation coefficient. What the data represent isn't super important, but kind of the shape of the data perhaps is helpful to help us navigate generating this plot. Okay, so again, we're going to start with a little bit of review of stat summary. So we'll take eData and we'll pipe that to ggplot. On AES, we'll map to the x-axis the week, the y will be Spearman, and then the color we'll go ahead and make condition, and then we'll geom point. And again, this is where we started last week. And again, seeing that there's 108 random permutation data, 108 of these blue technical variation, and 18 points for biological at each of 7 weeks. There isn't biological data for week 0 because my understanding is that the correlation is back to the previous time point for this biological condition. So what we'd like to do is go ahead and summarize the data down. So let's go in here and we'll do stat summary. As we saw last time, stat summary gives us a point range geometry where there's a point and then there's a range. By default, because we didn't give a summary function, it defaults to using mean_se. So this is the mean plus or minus the standard error. So what we'll use for fun data is median_high-low. So this is going to give us the median as well as a 95% confidence interval on our observed data. We now get our point and our range. I prefer the line range rather than the error bar, which has the cap up at the top. We saw this in the last episode again. I'm going to go ahead and comment this out just so I can quickly show you. We can modify this by doing like geom equals point, and this should give us just the center point, right? And then perhaps behind it, we could do geom error bar and add that in. And then that gives us our error bars. But of course, everything now is right on top of each other. And so we'd want to do a variety of position dodges. I find that these caps, to me, just look a bit busy. So I'm going to go ahead and not do that, but I'll use the default geometry of geom point range. But as I mentioned, these need to be dodged a bit. And the dodging moves things left and right. And so we can do position dodge. It wants a width. So let's go ahead and give it a width. So we'll do width equals 0.1. And we need a little bit bigger. So let's go up to 0.25. And I'm going to stop myself there. And I'm going to print this out to a file so that I know exactly where things are going to sit in the image. So I'll go ahead and do ggSave, and we'll do faceted x-axis.png. We'll do width equals 6, height equals 4. Very good. Yeah, it does need to be dodged a bit more. So let's come back up to where we did our dodging. Okay, so let's go ahead and dodge it. Let's go ahead and just try 0.5. So I think that nicely dodges the data. So one option, of course, would be to leave the data as they are, right? And not worry about this break. And this will send a very clear story to our audience that we have this break in the data. Something else that I want to experiment with is what happens if we put a line on the data. And so let's come back here now, and we'll do stat summary, and we'll then do geom equals line. And then again, we'll do fun.data equals median high-low. We don't need the high-low for a line, but let's see what this gives us. And this gives us a line through our data. I am noticing, however, that the points aren't dodged very well. For some reason, the green random is doing a good job, but the rest of these aren't so great. And I think that the green is working because that's in the middle, right? And everything else is dodged. So we could go ahead then, and in here, we could do a position dodge of 0.5. So I think that looks pretty nice. I think if I wanted to leave the line in, that maybe I would make the error bars black and make them perhaps less pronounced. But I don't know. Ultimately, I feel like there's a lot of stuff going on here. But if nothing else, I wanted to show you that we can connect the points using a geom line with stat summary. I'm going to go ahead and remove that last stat summary, and we're back here. So as I've been mentioning, my strategy that I want to take on for today's episode is to make basically two side-by-side plots. I want to make two facets. So to facet data, we need to be able to facet on a variable. So I'm going to come to my pipeline where I'm making my plot, and I'll do a mutate, and then I'll do phase equals, and I'll say if else week is less than 5, then I'm going to call it early. And if it's after 5, I'll say late. And then I'll pipe that into the rest of ggplot. So I'm picking two names here, early and late, that work because they're alphabetical. If things weren't alphabetical, if I did late and then early, then my facets might be in kind of a weird order. So now I'll have a column called phase that's made up of early and late. So then with this phase column, I now want to add that into my overall ggplot collection of functions. And we'll do facet wrap, and I'll do tilde phase, and I'll do nrow equals 1. And so now I have two facets, the early and the late. But what you'll notice is that they have the same x-axis, right? And I want the x-axis to be tight on the data. And to get that tight x-axis, we can do scale equals free underscore x. And so this should free up the x to only show us the x-axis that we need for the data. Now what we get are two equally sized facets, but the spacing is different in them, right? I don't want them to be the same size. This because the late has 2 time points, whereas the early has 5. So I want the late to be proportional to the early. To solve that, we're going to have to use a different facet function. So we'll do facet grid, and I can't use nrow equals 1, so I'll go ahead and remove that. So this gives me the same spacing that I had before with facet wrap, and so I need to add another argument, which is space. So we'll do space equals free x. And so now what we get is that we get proportionally the same size data for the early and the late, right? That each week is using the same amount of space, whether it's early or late, okay? And so again, the trick here was facet grid allows you to use space equals free x. That's not available in facet wrap, but it is available in facet grid. There are also free y values, or both free, period, for scale and space if you want to free things on the y-axis as well as on the x-axis. So I'm going to start making this look a little bit more publication quality. I'm going to start by turning on theme classic. So we'll do theme classic. This then gives me a clean background. And I've now got a broken x-axis, right? Which isn't exactly what I want. I would like to have a border around each of the panels. So I think what I'll do then is come in here and do theme panel.background and do element rect, and I'll do color equals black. And so now we get a border around our panel. Of course, it's not the same thickness, line thickness, that we have on our axes. And so I want to get them to match. And so here I'll do line width equals 1. So I think everything got thicker. And so I think we might also want to get rid of our X and Y axis. So let's go ahead and do that. So we'll do axis.line equals element blank. So there is a bit of an offset between the axis line and the panel background line, right? And again, panel refers to each of these facets or the plotting window itself. The next thing to get rid of would be these labels. And so to do that, so we'll do strip.text equals element blank. And we're basically going to be removing that strip, right? And so now we have two plots, right? We've got clear boundaries on our different plots. And let's go ahead and now turn to cleaning up our x-axis scale. And we can do that, as we've seen many times, with scale x continuous. And we'll do breaks from 0 to 9. And I forgot a plus sign here. And so now we've got cleaned up x-axis, right? So that looks pretty nice. I'm happy with that appearance. So let's go ahead and start cleaning up our labels. And so we can do that with labs. On the x-axis, I'm going to call it time, and I'll say it's in weeks. I don't like having units as my title. And then on the y, I'll do this Spearman correlation coefficient. And that's actually a row. And so in parentheses, I'll see if my HTML guessing works. I'll do row, semicolon, like that, and then a plus sign here. And I put in row, but I'm not using element markdown. So let's go ahead and do that. So we'll do axis.title.y equals element markdown. And of course, I need to get ggtext loaded. So we'll do library ggtext. That's the great package that allows us to use element markdown for our text elements. And so there we go. We've got our row, and perhaps we'd want this Spearman correlation coefficient to go over 2 lines. And so in here, I can do BR. And so that's HTML for a line break. And so that looks pretty decent. Now I want to get rid of the title on my condition. And we can come back here into our labs. So I'll do color equals null. So I'm not a fan of the border on the key. So we'll modify that with legend.key, and that takes element rect. So we'll do element rect color equals white. So again, that gets rid of the border around our plotting symbols. Let's go ahead and make the text a little bit more attractive, I'm going to match the language that they used in the paper. And we'll probably give it some nice color. So we'll do scale, color, manual, and we'll do breaks equals, and we'll do biological, technical, and then random. And then the labels will make biological variability, and then technical variability, and I need to get that in quotes. And then we'll do random permutation, which is what they had called it before. And then we need our values, the colors that we want to use. And so biological, I believe, was Dodger blue. It's my favorite color. And then technical, let's do dark gray. And then random was dark red. Okay, so we'll go ahead and add that. And so now we have the color is correct, but the order in the plot is not correct, right? So within a single time point, it goes biological, random, technical. I want it to go biological, technical, random. I know it's a small point, but it will show you how to do these types of things of changing the order of our data. And so I'll do that in this mutate statement. Well, I'll take condition and make that a factor, and that'll be a factor operating on condition. And then our levels, I'll do biological, technical, and random. And let's go ahead and put this on a separate line so it's easier to see. And so now we get that separate ordering, and that looks pretty good. I'm going to go ahead and put the legend across the bottom like they had in theirs. That'll also free up a whole bunch of space on the right side here. And so let's do that here with our legend key. I'll put a comma there and then do legend.position, and we'll do bottom. So good. Now there's a bit of spacing between the bottom of the plot and the top of the legend. So we'll do legend.box.spacing, and that takes a function of unit. And so let's start with 0 and PT, and that PT needs to be in quotes. So I think this looks pretty good. As we typically see when we go horizontal, the spacing between the text and the symbol, and then the symbol to the text, looks pretty similar. I'm not a fan of that. And so what I'm going to do is modify the width of the symbol. And so we can do that in here with legend.key. The symbol is called key. And then we'll do width, and I'll do unit. Let's start with 0. Oh, and it needs the units. So we'll put in PT. And that tightens everything up and doesn't have any margin between the text and the next plotting symbol. Let's go ahead and space things out with a margin. So we'll do legend.text equals element text. And then we'll do margin equals margin. And then the right-hand margin, I'm going to go ahead and put to 10 points. All right, so that gets us spacing between our text and our symbol, but our symbol runs right into the text. So maybe we'll go ahead and put a left. So let's do left equals 3. And I think that looks pretty good, that we now have spacing between our 3 legend elements. The last thing I want to do is do something about this plotting symbol, the glyph as they call it. This is a glyph for point range, where we have a point and then the range, right? I would prefer to just have a point. And so we want to change that. So the way we can change that is to come back up to stat summary, and we're going to give it an argument, key glyph. And this is a relatively new argument in the last year that allows you to change the symbol that is shown in the legend. So it's not going to change the plotting symbol in the plot, but what shows up in the legend. And so here then we can do point. So now we see that we've got the plotting symbol rather than the line. But I had liked the big juicy plotting symbol that was here before. I just didn't want the vertical line through the data. So to make that bigger, we can come back up to scale color manual, and we'll use the guide's argument, and we'll then do guide_legend, and then we'll do override.aes. And so this is going to override the shapes or the colors or the size of the symbols that are being shown in our mappings. And so here then we can give it a list, and we can give it any of those aesthetics that we want to modify. And so here we could say list size equals 2. And I think it's supposed to be guide, not guides. And so that's, I think, a nice size. Now, something that you might want to do is change like the color, right? So we could perhaps do color equals yellow. And so now all of our plotting symbols are yellow, although in the plot, they're not yellow. So why would you want to do something like this? Well, I would do something like this, or have done something like this, where maybe I have two types of variables. And so one variable, I might want to do a plotting symbol, and another variable, I might want to do a color. And so instead of having, say, 3 and 3, so 9 total combinations, I might make the plotting symbols all like gray. So I'll have 3 different gray plotting symbols, and then I'll have 3 colors that perhaps would be a square indicating the color. And so I then leave it to my audience to figure out how to interpolate those two so that if they see a red square versus a green triangle, that they can make that combination themselves. And so to do something like that, you're going to have to come in here and modify this guide equals guide legend argument in your scale color manual or your scale shape manual or whatever it is. So I don't want my color to be yellow. I just want a big juicy circle, and we'll roll with that. And so I'm missing a parenthesis here. So I'm pretty happy with the way this turned out. For these data, I'm not totally sold that we need to have any kind of break in the data. Maybe like including 5, 6, and 7 wouldn't have been the end of the world. But the problem with a break in the axis is that if it's not crystal clear to your audience what's going on, that there's kind of 2 different sets of data here, then mentally they'll forget that. They'll kind of black that out, if you will. Again, let me know what you think about this strategy to dealing with a gap in data on the x-axis. I haven't seen this on the y-axis, but I think this is a pretty effective tool that is a good compromise between having a break in the x-axis for time's sake, but still having that gap, but also then having kind of a psychological boundary shown with pixels that kind of groups our different sets of data. Experiments are hard and they're expensive, so I totally get that there might be a gap in time in kind of how we're collecting data. And I know if this were me, I might be wondering, why did I do 8 and 9? I should have just done 5 and 6, or I wish I'd have gotten 0.6, so I could have just thrown all the data together and been happy with it. Again, on the y-axis, I don't know that this would work on the y-axis. Other strategies, like using a log scale on the y-axis, is very effective for kind of bringing your data together, and then also just kind of questioning, if you have a really tall bar, do you need to show these really tiny bars on the side, right? I don't know that that's necessarily most effective, but you might think about other ways of scaling your data if a log scale doesn't work. Anyway, let me know what you think of this approach, and perhaps we'll circle back to this in a future episode. These types of plots with breaks in the axes are certainly common enough that I'm sure it'll come up again in a future episode. So let me know what you think. Anyway, please make sure that you've been telling your friends what we've been doing here on Code Club. Make sure that everyone you know is subscribed, and we'll see you next time for another episode of Code Club.